Hello, I'm Rahul Baghel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you all to the course on Industrial Automation and Drive. Today, we begin with our 19th lecture on PLC Counter Programming Part 3. In the previous lecture, we covered one-shot instruction, which include ONS, OSR and OSF instructions and some down counters. As you see in the diagram, the operation of down counter is similar to the up counter, but the only difference is it accumulator start counting in downwards directions or decreasing order. As you see in the diagram, the down counters also have two bits, two output bits. First one is CD bit and the second one is done bit, right? Let's take example to understand the operation of down counters. In this case, you can see the first input, that is I colon 0/0, is connected to the binary output, that is B3 colon 0/0, and in the second rung you can see here the B3 colon 0/0 is connected to the down counters, and the address of down counter is C5 colon 0. And the most important thing is here, you can see here the accumulator value is 5 and the preset value is 0. Right? Means the accumulator value is greater than the preset value, right? And in the third rung, you can see the done bit of counter is connected to the output, that is output address is O colon 0/0. And in the last rung, I am again using another switch to reset my counter, and the address of that switch is I colon 0/1, and the reset bit address is similar to the down counter address, that is C5 colon 0. In this diagram is the program mode, right? In this case, preset is 0 and accumulator value is 5. When I changes program mode to run mode, as you can see in this diagram, in the first case, initially the I colon 0/0 is 0. But when I changes program mode to the running mode, you can see the done bit is high, right? In the third rung, you can see the C5 colon 0/done bit is high, and because of that, the output connected to the done bit is also high, right? So what happened here? When accumulator value is greater than the preset value, down counter provides the done bit, right? In the previous cases, for the up counters, when accumulator value is equals to the preset value, then only my up counter provides the done bit. But in case of down counter, when accumulator value is greater than the preset value, then done bit is high. Because of these condition, you can see here the done bit is high, right? Let's take another case. When I press the input switch, that is I colon 0/0 is 1, because of that my binary output B3 colon 0/0 is 1, and because of that my down counter gets the supply. And I already mentioned, when the down counter gets the supply, its accumulator counts in decreasing order. That's why the accumulator value goes down by 1, that is value 4. As you can see in the diagram, in this case you can see my CD bit is also high because my counter start counting, that's why CD bit is high. But you can see the done bit is also high, right? So the output is high, right? Let's take third case. When this on and off process is repeating again and again for the 5 times, when accumulator value goes to 0 and accumulator value is equals to the preset value. In this case also you can see my done bit is high, that's why my output is also high, right? This is the most important case, you just noted down here, because in the previous cases, as I already mentioned, in the up counter, when the accumulator is equals to preset, my done bit is high. But in the down counter, here also the accumulator is equals to preset, or when the accumulator is greater than the preset, the done bit is high, right? then only my done bit is high, that's why my output is high, right? Now again, let's take another case when accumulator value is less than the preset value, means I am again changes the state of my input switches, that is I colon 0/0 to the 6th time. Then my counter gets the supply and it changes accumulator value 0 to -1. You can see here in this case my done bit goes low and my output connected to the done bit is low. So this is the major difference between the up counter and down counters. In up counters, my done bit is high when the accumulator is equals to preset value, and in case of down counters, when the accumulator value is less than the preset value, then only my done bit will goes low, right? So with this example, we found some major conclusions. The first conclusion is when the accumulator is equals to preset value, then also my done bit is high. But in the other cases like T on timer, T off timer and my up counters, all the times this type of condition is final conditions when accumulator is equals to preset. My second conclusion is this is the main drawback of down counters because the done bit operate when accumulator is less than the preset value, means in previous example we want process will happen 5 times. That's why I set my accumulator is equals to the 5. But actual process happened the 6th time, then done bit will operate, right? I think you understand the operation of down counters. So let's take another examples to understand the counter operations. In this case, you can see here I'm using up counter and down counter, but you can see the address of the up counter is similar to the address of the down counters, right? See, the address of the up counter I'm using is C5:0, but the address of the down counter is also I'm using C5:0, right? And you can see in the diagram for the up counter I use I:0/0 switch, but for the down counters I use I:0/1, right? In the third rung you can see my CU bit, that is C5:0/CU bit. CU bit means the up counter bit is connected to my first output, that is O:0/0, and in the next rung you can see the CD bit, that is down counter bit, that is C5:0/CD bit is connected to my another output, and the output address is represented by O:0/1. And in the next rung you can see my done bit. Done bit is means the counter done bit, the up counter done bit and the down counter done bit, because done bit is same for the up counter and down counters, right? Because address of the counter is same for the up counter and down counter, that's why in this case we have only one done bit, right? So this done bit represents the done bit of up counter and the same time the done bit of down counters. Address of the done bit, that is C5:0/done bit is connected to the another output, and the output address is represented by, that is O:0/2. So in this example my final output is represented by O:0/2, right? And in the last rung you can see my reset button is connected to the another switch, and the address of that switch is connected to the I:0/2, right? And the reset button address you can see here, that is C5:0, right? So let's take first case when both the inputs are 0. Both the inputs means I:0/0 and I:0/1, both inputs are 0, means my up counter and my down counter both doesn't get supply, right? That's why accumulator for the up counters you can see here the preset value is 5 and the accumulator value is 0, that's why it doesn't provide the done bit. But in case of down counters, you can see here, I'll provide the preset value 5 and the accumulator value is 0. That's why the preset is high and accumulator is low. That's why the down counter also doesn't provide the done bit, right? So all the bits are 0. That's why the output connected to the all the CU bit, CD bit and done bit is also 0. That's why all the outputs are 0, right? Let's take another case. When I press my first switch, that is I colon 0/0 equals to 1. You can see here my up counter is start counting in increasing order. My accumulator value goes 0 to 1. But the same time you can see in the down counter accumulator value is also increasing by 1, right? Because when it's get the supply, right, it doesn't get supply because the address is same for the up counter and the down counters. But in this case you can see here my CU bit is high only and my CD bit and my done bit is 0, right? Because of that you can see here the first output, that is O colon 0/0 is high only, and the another two outputs, that is O colon 0/1 and the O colon 0/2 is in off state, right? I am only changing the state of first switch. That's why the up counter changes their states from CU bit become high, right? Let's take another case. When I changes the second switch states, that is I colon 0/1 to normally open to normally close. In this case, you can see here my down counter changes their accumulator value 1 to 0, means it start counting in decreasing order, right? And you can see the up counter accumulator value is also getting 0, right? In this case, you can see here the down counter bit, that is CD bit, has also become high. That's why the output connected to the CD bit is also high. That's why O colon 0/1 is high. But in this case, you can see my done bit is 0. That's why the output connected to the done bit is 0, right? Let's take another case. Or you think, as you see, my up counter increase my accumulator value by 1, and when the switch I colon 0/0 goes on and off, and my down counter decrease accumulator by 1 when switch I colon 0/1 goes off and on. So you think and try to find the condition when my done bit is high, right? Because my up counter increase the accumulator value and my down counter decrease the accumulator value. So you find the condition when the done bit is high, right? For this, just take a quick recap for the up counter and the down counters. In up counters, we get done bit high when accumulator value is equals to the preset value. But in case of down counters, we get done bit high when the accumulator is greater than the preset value, because in down counter counts in decreasing order and done bit goes low when accumulator is less than the preset value, as I just explained in 5 minutes before. Or you can say that in case of up counter we set preset value, and in case of down counter we set accumulator value for smooth counter operations. The fourth case, to make done bit high, the first switch, that is I colon 0/0 switching means 5 times or goes on and off for the 5 times, then the accumulator value is 5 and the preset value is 1. That's why the first counter, that is up counter CU bit, goes 1, and the same time the down counter CD bit is also 1, and when the accumulator is equals to preset, my up counter provides the done bit. That's why the done bit of the counter, that is C5 colon 0 slash done goes high. So in this case, when all the bits are high, that's why the output connected to all the bits is also high, right? As you see in the diagram, I am changing the states of first switch 5 times. That's why the done bit is high and the output connected to the done bit is high, right? Let's take another case, that is fifth one. When I press my last switch, that is I colon 0 slash 2, which is connected to the reset button of my up counter and the down counters, you can see here, when I press my last switch, that is I colon 0 slash 2, it reset my both the counters, and you can see here the accumulator value goes to 0 for the up counters and for the down counters as well as. Like, so in this case, when the accumulator is reset, you can see here the CU bit goes 0, the CD bit goes 0 and the done bit goes 0. That's why the output connected to these bits are also goes 0. That's why all the output goes low, right? I think you understand the operations of up counters and the down counters, right? Let's take another example related to the compare instructions, which is remaining in the previous section, right? So this example related to the NEQ instructions. As you can see in the diagram, the NEQ instruction is connected in the first rung. You can see in the diagram the NEQ instruction is connected to the input side, means it is input instructions, right? And with this NEQ instructions, I connect the output, that is B3 colon 0 slash 0, right? And you can see in the second and the third rung, I am using two up counters. The address of the first up counter is represented by C5 colon 0 and the address of the second counter is represented by C5 colon 1. I am using two up counters, right? And these two up counters are connected with the two switches. The address of the first switch is I colon 0 slash 0 and the address of second switch is I colon 0 slash 1. So the operation of NEQ instructions, NEQ means not equals to instructions. You can see the diagrams. The NEQ instructions take two inputs for source A and source B. You can see in the diagram the source A address is C5 colon 0 dot accumulator and the source B address is C5 colon 1 dot accumulator, right? Means my NEQ instructions provide the outputs when both the sources, means source A and source B values are not equals, right? And you can see in the last two rungs, I am using another two switches to restart my two counters. So, and the address of two switches are I colon 0 slash 2 and I colon 0 slash 3, right? So in the first case, when you can see in the diagram, when both the accumulator value is 0, when both the accumulator value is 0 means this accumulator value goes to the source A and the source B, means source A is equals to 0 and source B is equals to 0. Means both value are 0, means both value are 0 and equal. Because of that, the NEQ instruction doesn't provide any output. That's why you can see my binary output is low, right? Let's take another case. When I changes the states of my first accumulator by switching my first switch, that is I colon 0 slash 0, when I press my first switch, the first counter accumulator value goes to 1 and when I press again, its accumulator value goes 2. In this case, what happened? The source value changes from 0 to 2, and the source B value, you can see here, suppose I'll change the second accumulator value, that is C5 colon 1 dot accumulator value with the use of second switch. That's why the accumulator value also changed from 0 to 1. So in this case, you can see here the source A value is 2 and the source B value is 1, because the first counter accumulator value is 2 and the second counter accumulator value is 1. In this case, you can see the source A and source B is different. That's why means they are not equals. That's why my NUK instructions provides the outputs. As you can see in the diagram, my NUK instructions provide the outputs. That's why the outputs B3 colon 0 slash 0 is high, right? And to reset my both the counters, I am using two switches as I already mentioned, that is I colon 0 slash 2 and I colon 0 slash 3. When I press my I colon 0 slash 2, my first counter is reset, and when I press I colon 0 slash 3, my second counter is reset. When both the counter is reset, in this case also, my accumulator goes to 0, and in the same time, the source A becomes 0 and the source B becomes 0, means in this case also the both sources are equal, and if the both sources are equal, my output connected to the NUK bit again goes to the 0, right? So NUK instructions means not equals to instruction provide output when both the sources are not equals. Source A is not equals to the source B. The value of source A is not equals to the value of source B, right? Let's take another example related to the LES and GRT instructions, right? In this case, LES means less than and GRT means greater than. So you can see in the diagram, first is LES instruction is connected in the first rung, and in the second rung GRT instruction is connected in the second rung. Means these two are also the input instructions, that's why it's connected to the input side, and two outputs, that is O colon 0 slash 0 and O colon 0 slash 1 is connected to the LES and GRT instructions respectively. And in the third rung and the fourth rung, you can see in the diagram, I am again using two up counters. The first counter address is C5 colon 0 and the second counter address is C5 colon 1. And to operate these two counters, I am again using two switches, that is I colon 0 slash 0 and I colon 0 slash 1. And you can see in the diagram, the last two rungs, I am again using the reset buttons for the both the counters, and with the use of two switches. The first counter reset switch is C5 colon 0, which is connected to the input switch I colon 0 slash 2, and the second counter reset switch is C5 colon 1, which is connected to the I colon 0 slash 3 switch, right? So let's take how it's operate. LES instruction means less than. You can see in the diagram, LES instruction also take two inputs for source A and source B. So I'll provide the first counter and the second counter. First counter accumulator as a source A and the second counter accumulator as a source B. In the same time, you can see the greater than instruction also take two inputs, the source A and the source B. For the source A, I am providing the first counter accumulator value, and for the source B, you can see in the diagram, the second counter accumulator value is provided, right? So you can see here what happens. Less than means when the two counters accumulator value is less than, means source A is less than the source B, then the LES instruction provides the high outputs, otherwise it provides the low outputs, right? And in the case of greater than, you can see here when the source A is greater than the source B, then only this instruction provides the high outputs, right? So you can see in the next case, suppose I am changing the state of first counter with the switch I colon 0/0, and you can see here the accumulator value changes by 0 to 1, and the same time you can see here my second counter accumulator value changes by 3 with the switch of I colon 0/1, right? So in this case you can see here my first counter accumulator value is 1 and the second counter accumulator value is 3. You can see the LES instructions. LES instruction, the source A value is 1 and source B value become 3. So in this case, when the source A is less than source B is true, that's why the LES instruction provides the outputs, that is O colon 0/0 is high, right? And you can see in the next condition, when I'm again changing the states of my counter values, and you can see here when accumulator value is greater than, means source A accumulator value is greater than the source B accumulator value, my GEQ provides the outputs, that's why the output O colon 0/1 become high, right? LEQ is less than equals to and GEQ is greater than equals to, right? LEQ provides output when source A is less than to the source B, and greater than GEQ provides output when source A is greater than the source B, right? And to reset both the counters, I am using I colon 0/2 and I colon 0/3 switches. So when I press I colon 0/2 and I colon 0/3, both the counters are reset and this accumulator value goes to 0. And when the accumulator goes 0, in this case my LEQ output goes 0 and my GEQ output also goes 0. So that's all for this lecture. In this lecture we covered the down counters and compare instructions and their examples, right? In down counters and up counters, the major difference is my down counters count in decreasing orders and my up counter counts in increasing order, right? And the major drawback in the down counter is it provides the done bit low when the accumulator value is less than the preset value. Means if I want 5 times, then I provide my accumulator value is 4, then it counts the 5, right? And the similar way, I use the comparative instructions, right? And their examples also in this program. I think this programming is clear to you. In the next session, we will explore more on the star delta starter and their PLC programmings. As we know, the star delta starters are used for the induction motors, for the 3-phase induction motors. And in the previous lectures, Dr. Simpir Alhan will cover the basic principles of electrical machines and the drives part. So we are start in the next lecture. So we will explore in the next lecture with the star delta starter and their PLC programmings, right? Thank you and happy learning.